In this video, we're going to take a look at being able to format our output. And in the previous video, we took a look at how to use some of the built-in commands to execute mathematical sorts of statements. So one thing that we can do is we can certainly assign our output to a specific variable. And so if I want to call a variable, or if I want to assign 5 to variable p, not surprisingly, I just write the statement p equals 5. You might remember from the first video, a semicolon suppresses the output. So what MATLAB does is it computes it, but it doesn't print it to the screen. And I don't necessarily have to assign it to a specific, just a single variable. I could assign it to a whole word, such as number, as long as that word is not reserved, meaning that we couldn't use like SIN, because remember that represents sign, or ATAN, because that represents arctan. You probably remember the clear all and also the CLC functions. So we probably remember this. And if I ever just want to reference the last output, I can use ANS. All right. Now, if I want to go through and specifically format the output, first of all, what I would do is I would assign the output to a variable, and then I would use these different sorts of formatting commands. All right. And the most important one that I like to use is the fprintf function. Now, fprintf is essentially going to print whatever's in x, if x is a string, all right? And I'm going to show you what to do if for some reason you want to print something numerical and also format it to a certain number of decimal places, or if you want to print it as an integer or something like that. So I'll go through the different permutations of that. If you want to print a new line, so if you want to just basically hit the enter key, you're going to type in \n in the fprintf statement. All right, so maybe right here, and I'll show you this once we go through and do a couple examples. Then I would just type in x\n, and it would just hit x, and then it would hit the enter key. If I want to use the tab, I would use \t, and then %d means that I'm going to reference a variable and print that variable out as an integer. %f is going to be a decimal or a floating point. And if I want to round that to a specific number of decimal places, I could just say 0.4 would round that to 4 decimal places. And if I want to use 12.4f, what that would do is say that I reserve 12 characters. 4 of those are reserved for decimal places. And then anything else, we just have some blank spaces. If I ever want to print out a string, and this is more for our computer science folks, meaning it's non-numerical, I could print out %s. And if I want to print out a single character, %c. And we already saw the sim function in a previous video that just converts a value into a symbolic variable if necessary. So just to kind of give you a really brief overview of what we just saw there, 3 examples of which we saw in the previous video is we want to go through and we want to print out the format, or we want to print out the answer, but we're going to format it with an appropriate message, and we're also going to round to 8 decimal places. All right, so let's just do this really simplistic example first. So remember, when you start your file, CLC clear all, and I'm just going to assign A, or I'm going to define the answer to whatever we have here, our 75 plus 27 minus 33. I'm going to assign that to the variable A. All right, and I'm going to suppress it. So 75 plus 27 minus 33. I think that's what we had. All right, and I'm going to suppress the output. All right, so when I run it, there's nothing because I suppressed it. Remember the first time we did this? I'm going to go ahead and eliminate this really quickly just to show you. The first time we did it, we had ants equals 69. All right. Well, now if I have it in A, now it has A equals 69. And if I have the semicolon there, then nothing's going to happen. It suppresses the output. Now I'm going to use my fprintf statement. All right. So I'm going to say fprintf, and I'm going to use one of these apostrophes. And we're going to say problem 1 answer is, and I'm going to use a colon, and then I'm going to use a \n, all right, and I'm going to close that out. Now, let me just run this, all right, without anything else. So I'm going to run it, and it says problem 1 answer is, and then it just has an enter here, all right, so it just returned, but it didn't print anything out. So if I want to get some printout from that, let's do this. Let's do %f before that, and I'm going to say comma A. All right, so what this means is that it's expecting some sort of variable, and A is the variable it's going to reference. All right, so this is the command that you're going to use here, and I'm going to go ahead and execute this. and it says problem 1 answer is 69, which we knew. Now let me change this to %d, and that makes it an integer type. All right, so remember %f is a floating point type, which gives you decimal points, and then %d is the integer type. All right, which just tells you that there's not going to be any sort of round off there. Now, I believe our instructions told me to round to 8 decimal places. So what I'm going to do is I'm going to say %.8f, and I'm going to run that. And notice we get 8 decimal places, although it's not really appropriate because we know it's going to be precisely the answer 69. Right? Now let's do the next one, and I'm going to assign that to variable b. All right, and that was e to the third log 27 log base 27 or log base 725 minus 420, absolute value of that. So remember, we used the absolute value, and we had absolute of exp to the third power plus, remember, it was log 25 divide log 7 minus 420. All right, and we're going to close out our absolute value and just make sure I type that in correctly. That is correct. All right, and I'm going to suppress the output, and I'm going to do an fprintf, and I'm going to say problem 2 answer is colon, and I'm going to say %.8f \n. All right. Now, what this again means is that I'm expecting a variable, and I'm going to print it out to 8 decimal places, and then the \n means I'm going to hit enter after I've printed it. And remember, that's assigned in B. So I'm going to say comma B and then close that out. So now if I run it, I have problem 1 answer and problem 2 answer. All right. Now let's assign problem 3 to C. All right. And remember, that was going to be 2 times the sine of pi over 2. And then we had plus 4 to the third, and then minus arctan, so atan, I think it was arctan. Let me check just to make sure, arctan of 0. Right. And then we're going to divide that by, we have our e to the 0, 32 sine squared of 2, 32 cos squared of 2. So we have exp of 0 plus 32 times parenthesis sine of 2 squared plus 32 times parenthesis cos of 2 squared. Right? And then we close our parenthesis out, and I'm going to suppress this. And one of the things that's really nice is we could just copy and paste this. So all I did was I just went up here, I highlighted it, Control C, and then let me get rid of this. And I could just do a Control V to copy and paste it. And since it's the same format, problem 3 answer is, and I'm going to call variable C this time. So now if I execute this, I have the answer to problem 1, problem 2, and problem 3. All right, so pretty cool now that we can go through and get the output for all of these and format them to specific decimal places. All right, so now that we know how to go through and use built-in commands, and we know how to format output a little bit, the next video what we're going to do is we're going to take a look at how do we graph functions or relations in 2 dimensions.